Hey, folks, I want you to set up your notes just like this. We're talking lines again, and I don't want that to be off putting. You might say, this is going to be too easy for me. But I think you're going to see that the function notation is really where we're trying to grow. We're trying to get better at understanding this kind of stuff down here. But let's just do a quick review so nobody starts the assignment off going, oh my gosh, he said this is going to be easy. All right. So I'm going to show you what the textbook assignment kind of looks like, but we're doing it on my math lab. So it might look a hair different than this. They're going to give you an equation, right? Notice they're using function notation, and the equation is going to be linear. And they're going to ask you what's the slope, the y-intercept, all that kind of stuff, right? So let me take their 2x plus 3, and I'm going to put that down right here. So we have y equals 2x plus 3. We know the slope is the 2 because our equation is mx plus b, right? Slope-intercept form. We know the y-intercept is 0, 3. And this might be a little weird. The average rate of change is like the slope between any 2 points. Well, on a line, the slope's always the same. That's what makes it linear, right? Not trying to insult anybody's intelligence here, but we're up 3 spots. 1, 2, 3, boom. And then we're going to have a rise of 2 and a run of 1. So between these 2 points, the slope is 2. Between the next 2 points, the slope is 2. The slope always stays the same. Otherwise, our line is not a line, right? So that kind of wiggled a little bit. Sorry about that. So our average rate of change is going to be the same as the slope. Increasing? Yes, it's increasing because it's a positive 2. Positive 2 means it's increasing. If you had a negative slope, it would be decreasing, okay? Decreasing. If it had a 0 slope, then it's a constant function. So you might say, well, that's a little weird. What's a constant function look like? Let's say you had like y equals 7. Do you notice it's like y equals 0x plus 7? See, my slope is 0. All right, so let's get to the real meat of today's assignment. It's ones like this. How do we interpret problems like that? Well, here's what they're saying. When is f of x equal to 0? They're saying the y value is equal to 0. So if I set 4x minus 1 equal to 0, I add 1 to both sides, and I divide by 4, I end up with 1/4. That means that I'm at 1/4 comma 0. It's really saying the y-intercept, right? So let's graph that guy real quick. If I go to -1 and then I do a slope of 4, 1, 2, 3, 4 over 1, that's going to be at 1, 3, right? So let me draw my line in here. All right, so there's one of my lines. And the y-intercept is right there. That's at 1/4, right? Let's look at this next one. B says, when is the y value greater than 0? That's really the question. When is the y value greater than 0? Well, aren't these y values right here all greater than 0, right? Those are all positive y values going up forever. So what x values, that's really what they're saying, what x values generate those y values? It's all of these x values going this way. So the way I answer my question on part B is maybe with an interval. You could say 1/4 out to infinity, or you could answer it as an inequality, a set notation. They might have x such that x is greater than 1/4. These are the kind of questions where the real rub happens. And do we understand the function notation? I hope you agree with me. I hope this is like, oh, I see what we're trying to do. We're trying to get better at function notation. It's saying, when is f of x equal to g of x? Well, let's graph g of x and see what happens here. So if I go to 5, so let's see, that was 3 right there. So I got to go up 4, 5. So here's 5. There's my y-intercept, right? And then it asks us to have a slope of -2. So we go down 1, 2 over 1. Oh, look at that. This line, geez, I wish I could draw a line better with this tool. This line hits right there at 1, 3. So on part C, when I graph it, I can see the solution is 1, 3. But if I wanted to show some algebra, I might set one function equal to the other function like this, 4x minus 1 equal to -2x plus 5. And then I would add 2x to both sides. Oh, shoot. Let me just do that in my head. If I add 2x to both sides, I get 6x. If I add 1 to both sides, I get 6. Divide by 6, and I get x equals 1. See, my x value is 1. my y value, I got to take the 1 and plug it back into one of the functions. I could do it in either function, right? So I'll do g of 1 since the g function's sitting right there. Negative 2 times 1 plus 5 equals negative 2 plus 5, which is 3. That's where my y value comes from right there. All right. Hey, how about this question? When is f of x less than or equal to g of x? So let's put the f of x function more in red. Okay, we want f of x to be below the blue function, let's call it, the g function. So g is in blue and the f function is in red. When is the f function below the g function? Well, for or equal to it, right? It does say or equal to right there. So I'm going to say everything at 1/4 or less. And the way I would do that in function notation, right? So I'm doing part D right now. In function notation, I would have, we're going to go out to negative infinity, and we're going to go all the way over to 1/4, and we're going to include 1/4. If I was doing that as an inequality, as set notation, I have like x such that x is less than or equal to 1/4. All right. Boy, I hope I'm covering some of the stuff that you can see. Oh, I see where this is going to get a little bit more challenging. It might not happen right at the beginning of the assignment. The beginning stuff might be super easy. Hey, good luck, everybody. Thanks for watching.